Hello. In this video, we're going to talk about tangent lines at a given point. So we've already discussed tangent lines and how they come from secant lines. And that video, you can go back and watch if you need to refresh it. What we're going to do today is we're not going to visually talk about it. We're going to actually find the tangent line utilizing limits. So here's what we're going to do. Look at the definition. The slope of the curve y equals f of x at a particular point P is the number in this limit. So if you look at the f of x 0 plus h over f of x 0, this part right here, this should be recognizable for you. This is the slope of the secant line between 2 points, x0 and x0 plus h. By taking the limit, we're letting those 2 points get closer and closer and closer, so our secant line is approaching the tangent line. And that's what we're going to actually calculate and do today. So we're going to use our limit rules that we've learned to be able to figure all of this out. Let's see. So our example says, find the tangent line to the curve at this point, 1, 1. This is our curve, y equals x squared. You can see it in the picture here. So we have 2 points. Okay, this isn't the actual curve, but this is an example. We have 2 points, and we're going to let them approach each other. We're going to let h go to 0 until we find this red line here, our tangent line. So how do we do that? Find the tangent line. So first of all, to find a line, you need to know the slope. The slope of the line is the formula that you see in the definition above. The slope is the limit as we allow h to approach 0 for f of x0 plus h minus f of x0 all over h. Now, x0 is our specific point. H is changing, so we cannot plug in an h value until we're ready to take the limit. Don't take the limit until everything else is simplified, all the plugging in is done, the algebra is done. But x0, that is our point, so we can plug that in. So our point is x0, y0. So x0 is 1. That's what we're going to plug in here. Limit. Don't forget your notation. As h approaches 0, we have f of 1 plus h minus f of 1 all over h. So again, h is h. You cannot get rid of that until you take the limit. All right, if we were to take the limit at this point, we would end up with 0 over 0, so that's not okay. We have to do some algebra. Let's actually plug in our function. So our function that we were given, f of x equals, the y value, remember, is f of x. So f of x equals x squared. We need f of 1 plus h. So I'm going to go over to the side over here, and I'm going to find f of 1 plus h. So if our function f of x was x squared, and I replace x by 1 plus h, I do the same thing on the other side. Wherever I see an x, I put 1 plus h. Notice I'm putting parentheses because all of that is going in for the x. So all of that has to be squared. So what does it mean when you have parentheses squared? Parenthesis times itself. So 1 plus h times 1 plus h, FOIL it out, 1 plus 2h plus h squared if you FOIL it. So this is what we're going to plug in for f of 1 plus h. So let's go back over to my left-hand side here. The limit as h goes to 0 of. So my first function, f of 1 plus h, is what we just found. 1 plus 2h plus h squared. The formula says then we need to minus f of 1. Well, what's f of 1? We can calculate that. Just plug 1 in for x, square it, and you get 1. So f of 1 is 1. H on the bottom is still h until we take the limit. Now, you can try and take the limit. Again, if it's not going to work, you can get 0 over 0. So we need to simplify. So keep your limit notation because you're not ready to take it yet. Now, we have a 1 in the parentheses minus a 1 outside. Those two cancel each other out. So we end up with 2h plus h squared all over h. You can try to take the limit, but it's still going to give you 0 over 0. You've got to do some more algebra. What can we do? Every single term has an h. So you can reduce every single term by h. Or you can think of it the other way. You can factor h out of the numerator and then cancel with the h on the denominator. So limit as h goes to 0, we're going to cancel 1h from each area, each term. So we end up with 2, no h's, plus an h. Again, try and take the limit. This time it's going to work. let h go to 0. So we end up with 2 plus 0, which is 2. What did we find here? This formula gave us m, the slope of our tangent line. Okay, but what did the question actually ask us to find? Find the tangent line at 1, 1. So this is the slope. Now we need to find the line. So how do we find a line? Well, you have two formulas you probably remember. One is y equals mx plus b. This is the slope-intercept form. Or you have the point slope form. Y minus y1 equals mx minus x1. You can use either one. That is up to you. For the mx plus b, you do not have b. You'd have to solve for b. For the point slope form, we have everything we need to plug in. So we can plug in our point. Remember, our point was 1, 1. So y1 is 1, and x1 is 1. And we just found our slope. Remember, we're finding the tangent line, so we use the slope of the tangent line. And we plug that in, too. Now, when we give us an equation of a line at the end, we usually simplify. So our goal is to now rewrite it in the mx plus b form. So get y by itself and simplify the other side. So y minus 1 equals, I'm going to simplify the right first. What do we need to do? Distribute the 2. So 2x minus 2. And then, how do we get y by itself? Bring the 1 around. Add it to both sides. And our equation for our tangent line is 2x, negative 2 plus 1 is negative 1. This is the equation of the tangent line to the curve y equals x squared at the specific point 1, 1. If you had any other point or any other function, it would be a different tangent line. But for this particular curve, this particular point, that would be your answer. So that's how you find the tangent line if you're given a specific curve and a specific point. Keep watching and you're going to find out more about tangent lines. I'll see you in the next video.